I'm pleased to introduce Captain Steve Jangelis, who serves as ALPA's Aviation Safety Chair. Steve is relatively new in his position. He had taken over for Captain Hogeman. I know many of you know him. And he has done absolutely an extraordinary job. It's been a seamless transition. And I want to personally thank you, Steve, for making my job a whole hell of a lot easier. But anyway, thank you for all you're doing. Appreciate it. Now, Steve flies for a legacy airline and has served ALPA as steadfast safety representative for many years. The last panel for today is on cybersecurity concerns in today's aviation environment and the transportation industry's use and reaction to threat information. Steve, it's all yours.
Good afternoon, everyone, and welcome to our final panel discussion of today's conference. I'm Captain Steve Jangelis, as Joe said. I'm the Aviation Safety Chairman for ALPA. I'll be moderating today's panel discussing cybersecurity concerns in today's aviation environment. This is a subject that affects every one of our members, and one that we're just beginning to scratch the surface on in many respects. Now more than ever, commercial airlines rely on highly advanced information technology systems to optimize their businesses. The IT systems of highest concern to ALPA are those that interact directly with aircraft systems. Onboard networks are used to manage aircraft operations, including flight control and navigation. Aircraft systems are regularly updated with both software enhancements as well as updates to databases or other information. Some onboard systems are routinely connected to communication networks for the exchange of information at various times, both in flight and on the ground. Cybersecurity policies, procedures, and risk mitigations are increasingly needed to ensure aircraft do not become the victims of cyber-related accidents or incidents. For today's discussion, we put together a great panel of experts who can speak from varied perspectives related to this emerging threat to our industry. With that being said, it's my pleasure to introduce you to our panelists. Mr. Jens Hennig. Mr. Hennig is the Vice President of Operations for the General Aviation Manufacturers Association. Mr. Julien Touzeau. Julien is the Product Security Director at Airbus Americas. Mr. Doug Booth. Mr. Booth is the Director of Airborne Electronic Warfare and Cyber at Lockheed Martin. We'll now ask each panelist to provide their unique perspectives on the subject, and after, we'll begin our roundtable discussion. So, Mr. Hennig, please proceed.
Thank you, Steve. My name is Jens Hennig, and again, I'm with the GA Manufacturers Association. You may be asking yourself, why is there a GA panelist at an ALPA event? No, I'm not trying to expand my purview of work. I had the pleasure of being asked by the FAA a couple of years ago to co-chair with Boeing a group called the Aircraft System Information Security Protection Working Group. It's a working group that was stood up to look at one component of the cybersecurity problem, because there's not a shortage of areas: passenger reservation system, ground security, IT systems, you name it. This term, Aircraft System Information Security Protection, or ASISP, is the one that we built specifically focused on the airworthiness of the aircraft. So how does the aircraft stay safe, and how does now in the new environment that airworthiness also address aircraft system security? So we were stood up in June of 2015. We were given 14 months to do our work, and like with anything in aircraft manufacturing, it's an international effort. GAMA and Boeing co-chaired it. Justin had staff from Airbus actively participating, a number of other manufacturers, everywhere from the aircraft level to the equipment level, and also regulators from not only the FAA, the European equivalent, EASA, Transport Canada, ANAC, and among the US government agencies, DoD, DHS, and others. They were all at the table, and we wanted to basically set up the worldwide basis for how to keep the aircraft secure. So we finished the work in August of last year. There's a process, and ALPA participates in this one under the Aviation Rulemaking Advisory Committee, or ARAC. ARAC voted in favor of these recommendations back in September of last year. And if you would like to review the report, it's about 194 pages, written by a bunch of engineers. So I highly encourage you to dive into it. And it's available on FAA's rulemaking website. You just look for ASISP, and you can do a deep dive into that type of reading. So what did we recommend? We provide the agency 30 recommendations in 8 different areas. One of the recommendations is looking at future need for R&D. We're still learning about this field. We've learned a lot over the past several decades, but there is still an opportunity to advance our knowledge with respect to certain types of technologies and areas. So out of the 30 recommendations, one is FAA research related to go and look at specific systems. In the 29 that deal with policy issues, the first one that you'll probably see is one that governs the FAA's policy for the issuance of special conditions. Special conditions is a term that's pretty well known in the manufacturing field. It's been used for many years, but here in the room, who knows what a special condition is? All right, so I'll do a quick preview. As manufacturers, we're always pushing into new technology areas, and sometimes there are not rules necessarily in 14 CFR that says how we're going to do something. When we encounter those issues, and it's quite common, the FAA, instead of issues a broad-based rule, we all know how long that often takes the agency, the FAA issues in the Federal Register a special condition that's applicable as a regulation to a specific make model aircraft. Over the past decade since the FAA started attacking this cybersecurity challenge, they've issued special conditions to address cybersecurity on a little over 24 aircraft models. There's models from Airbus, the A350 and the A380. There's models from Boeing, the new 737s, the 787. And in the GA space, you have a number of business jets, Cessnas, Learjets, Gulfstreams, and so forth that have had these special rules issued. So what the FAA asks us to do is look for the agency's policy. They've been issuing these. Is it the right type of policy? Is the content of the special condition approached the right way? How are we managing the threat? So if you go into the background of the report, you'll see the special condition policy written up. And it's probably the first thing that you're going to see out there in the public because the FAA has discretion to issue those kind of policies without the very cumbersome and lengthy rulemaking process. So it will be an evolution of what we've been doing for the past 10 years, but a much more targeted and specific policy. And it's not only a policy that's applicable to transport category aircraft, but it now has specific language that covers helicopters and small airplanes and certain types of systems and how you interact with it. In the other areas, and what we typically do with a special condition, when the FAA has issued enough of them, and it's a bureaucratic burden, you take the lessons learned from that and you roll it into the issuance of a regulation. Rulemaking is subject to all the usual processes, cost, benefit, and other things. So we know that's going to take some time, and we'll use those special conditions until then. But what the ARC provided is a risk-based proposal for how to amend Part 25. Part 25 is the rules section that governs transport category aircraft, the aircraft that you fly, and how to update the subpart that's called subpart F that covers rules for aircraft systems and equipment. We've written a new regulation. You can see the draft on the report. And in addition to the rules for Part 25 aircraft, we also have recommendations for other regulatory parts, helicopters, small and large, small airplanes, engines, propellers, and so forth. And we've told the FAA, obviously, to move forward with a risk-based process with respect to getting them out on the street. The rule is performance-based. You're going to read it and say, that's 5 sentences. This is a complex topic. So how is that actually going to work? Well, the FAA has a number of things out there. A lot of the things that we do as manufacturers is we build towards technical standards. A long way the way we've done things. Here in the United States, we have a group called RTCA. They own a lot of the standards for large aircraft. In Europe, there's one called EuroK. A lot of cooperation done there. And we have a committee called Special Committee 216, and I think Work Group 72 over in Europe, that already has issued standard for how I comply with a special condition. What we told that group to do is by the end of this year, by the end of 2017, is to update the existing standards for how we do the engineering vetting of the systems to make sure that they're sufficient and have them out on the street by the end of this year. And that work is progressing. We have a similar group for small airplanes. It's held by a different standards body, ASTM. I won't bore you with the details, but it's a more condensed and more targeted approach. Basically, we said the standards and the evaluation we should do for the next Cessna 172-like aircraft is probably going to be slightly different than the one that was used for the Boeing 787. It's going to be a different approach. We're going to achieve this end objective of the aircraft being secure, but that best practice is going to be held by ASTM. They're on a track to also be done this year. So we'll have a framework in place for both of those. Just as part of the opening conversation, and I never want to give a long monologue about things, so let's just, what else are we covering in these 8 recommendations? How do we deal with field level software? Steve mentioned that. That's something that we use to get new systems on the aircraft. There's guidance out there on that, but we discuss that in a little bit of detail in the report and provide some recommendations to the agency. Whenever we talk about cybersecurity, next gen is always a conversation. How are we going to secure next gen when it comes to the ground infrastructure? But also for the purpose of what I do as a manufacturer, the specific systems that interact with the ground system today that are more connected. What are the specific things that I need to do beyond the certification to harden, be it a transponder, be it data communications, be it PBN? So we've laid out not specific recommendations to the FAA, but a methodology and a process by which they should go through all the different standards for aircraft equipment that are used before next gen in the NAS, now in next gen even more so. How should we review them and make sure that they're sufficiently hardened to address the cybersecurity threat? The last part, and again, this is very much applicable to the people that you guys work for. After a manufacturer has delivered an aircraft and it's been determined to have sufficient security considerations to be meeting the standards. In this environment, we also have to maintain that security. Same way that I have maintenance instructions to keep the aircraft safe, part of those instructions that go out to the mechanics and associated procedures also now cover how do you keep those critical systems secure and in the manner that the aircraft is. So you'll see in the report a discussion about continuing operational safety considerations. How do I maintain my system? How do I maintain the systems that connect into the aircraft, such as a maintenance laptop? How do I make sure that that's secure so it doesn't cause something bad to happen on the aircraft? And then just to round out our entire safety process, there is safety reporting and logging recommendations in there as well. So that's the framework that we've laid out. Quick overview. I'll go back to you, Steve, now.
Great. Excellent. Great overview, and like you said, we could touch upon a few of those subjects. Some really great questions I've just thought of as you were speaking, and we'll get to those in just a little bit. But Julien, if you don't mind, if you'd like to go forward, tell us about Airbus.
Well, thank you, Julien Touzeau from Airbus Americas. I'm really pleased to be with you today. And I would like to thank you, ALPA, as well, for offering this opportunity to Airbus and Airbus Americas to maintain and strengthen this partnership and relationship we have with ALPA. As a permanent assignee, I will be your privileged contact now and in the future on that topic. Before going into depth by PowerPoint, I would like to draw the skin by giving you some insight and background info on how product security and cybersecurity in particular has been developed at Airbus. And I want to apologize for my poor French accent. So if it's not understandable, just raise a hand and I will repeat with an even worse French accent so that you can understand. So, well, Airbus is really taking very, very seriously cybersecurity topic. I wouldn't say a concern, it's a topic. It started, I would say, right after the 9/11 September events. And to be completely honest, at that time, not many people were working on cybersecurity at Airbus. Now, a few years later, it's a topic that mobilizes dozens of engineers throughout the world on most of our locations. So that's something we now take very seriously. 2 years ago, thanks to the experience that Airbus commercial aircraft has acquired in that topic, there was a CEO decision to set up product security offices in all the divisions of the group. So you now find people in charge of protecting our products, whether it's a satellite, helicopters, launcher, or airplanes in all the divisions. So I was in charge of setting up this office in Airbus helicopters, and I'm very pleased to be at Airbus and serving Airbus Americas for that. You addressed it. Thank you. This is typically the threat landscape that we use to communicate, just to show you that actually an aircraft, whether it's a satellite or a helicopter, is really just like a node of a network. and that threat vectors can originate from various origins. It's not only the aircraft itself and its communication devices and protocols with the outside world, it's also any cyber attacks that could occur on things like the ground communication, wired or wireless, but also every devices, portable devices that are used on ground by the maintenance operators to upload, download data, prepare flight, post-flight report. And above all, it's one of my key topic is security of the supply chain, and we have the chance to get back on that later on. But you see the threats, the exposure to threat, or the threat surface is really vast. And the thing is, the battle is highly asymmetrical because in the cyber world, one guy somewhere in the world can really give headaches to dozens of engineers at Airbus and probably at Boeing as well. So for sure, the entire industry is concerned, not only you guys and the operator and the maintenance operator of the aircraft, but the whole life cycle of the aircraft and the airplane is concerned with cybersecurity issue. And what we do, and I'll get back on that, is to adopt a risk-based approach. And risk management is key for that. And we, at Airbus, we conduct risk assessment at every step of this life cycle. It starts with the ideation, with the very first step of research. When we think of a new aircraft, we start building prototypes, etc. Cybersecurity issues is already part of the discussion. Can we steal data from the flight test instruments that are installed in yellow boxes, orange boxes on board the aircraft? That starts very early in the life of a program, of a new program. And of course, as a manufacturer, a lot of effort is done during the design and development of the aircraft itself. This is where we spend a lot of time in evaluating the risk that one onboard function could be hacked into with significant impact on not only safety but also operational reliability. But that doesn't stop there. We also look in lots of details about what could happen during the manufacturing of individual parts, the assembly of these parts, and especially the integration of avionics systems and everything related to communication devices, because a lot of things can happen as well during the manufacturing processes. And then we issue to our customers a security handbook so that they are able to operate in a secure way the aircraft that we deliver. And I'd like to mention also the importance of taking care of cybersecurity issues when decommissioning an aircraft. This is something we are now closely looking at because our customers and us, we have intellectual property in that aircraft. And when it is decommissioned, it's key to make sure that the aircraft is not going to the scrapping without making sure that it does not have this IP inside, whether it is the manufacturer or our supplier's IP, but also your information or those of your customers, or of the airline's customers. Sorry. So what is the Airbus approach, the key driver for managing this issue? It's the result now of more than 10 years. As I told you, it all started with the A380 because in September 11th, we were right at the beginning of the A380 program. And the A380, like the 777 and 787, are now highly communicating a device, I was about to say, but airplane. And after 10 years of experience and work on that topic, these are the key elements that we follow and which are driving our effort. First, we manage security and cybersecurity at the risk. There are other options. You can manage cybersecurity with a compliance-driven approach. Our approach is to manage it at the risk and to make sure that the effort we put is commensurate to the risk. So this is one approach. I would say that it's the less bad approach, because a risk-based approach has its own drawback, I would say, because we are evaluating the risk of a cyber attack to impact flight safety, but also non-safety related assets like the operational reliability and also the airline image, etc. And just like the definition of an asset is something you put value in, and everyone has a different definition of what they put value in. So what is the value of disrupting the operation in one airline is different from another airline. That's where this risk-based approach reaches its limits, because for safety, we know if the safety impact is catastrophic or hazardous, it's clear, and we follow the regulation, etc. For non-safety related impact, that's another story, and that's lots of discussion with our prospects and customer and with the regulator. We also insist on the benefit of a security management system that includes and takes care of cybersecurity in the airliners' places. I've visited many of our customers, and they are very mature in managing security through a documented security management system. But of course, today, cybersecurity is not part of these manual or processes. And we have put that in place inside Airbus. So now cybersecurity is really part of our processes, just like in our DNA. All of our engineers follow our documentation and knows what to do at every step of the design of an aircraft. But it should be, we really advocate and are in favor of having the whole industry following this approach. Each player in that field, our partners and suppliers, our customers, the maintenance operator, should adopt at some point in time, we think, a security management system that includes cybersecurity. The fast sharing of information on incident and threat is key. And on that point, some of our previous participants already mentioned it, but the role of the ISAC, Aviation ISAC, is key. We are very glad as Airbus to participate to it. And some of you know that the European counterpart of the US ISAC is on the way. We are a few weeks or months away from having the EU Aviation ISAC being up and running. And we learned a lot thanks to the US ISAC. And we foresee lots of interconnection between those two information sharing centers and working groups. We also focus our effort on accelerating the time to get a fix. When there is a cybersecurity incident, if it happens, then we need to be very quick. A typical time frame for updating one line of code in an avionics component, it's 2 years. From the day we have a request, our engineers start working on the modification, and the time it's flying, it's typically 2 years. You can understand it's not manageable if we have an attack on a system that shows there is a vulnerability in the system. We need to be able to react very quick. So time to get a fix as quick as possible, having shortcuts in the certification process. That's a topic we are discussing with the regulator. And being able to provide a workaround very quickly to our customers. Because from the time we discover, if we discover a vulnerability and the time it's updated, we need to provide the operator with a workaround as quick as possible. And last, yes, the cooperation. cooperation of us between all the actors of the air transport industry. With our competitor, we often claim that cybersecurity and security in general is not a competitive issue. So we are very glad and open to discussion with our partners and competitors on that topic. We do it on a regular basis. There is a so-called Club of Four on that topic, for those who know about it, where high-level representative of the main aircraft manufacturers are directly discussing and share valuable information and best practices on that topic. I would like to finish with our vision of challenges. So I wrote short-term challenges because actually I wanted to put mid-term, but when you read through it and when you look at the pace those topics are moving, then it's no longer a mid-term challenge. It's really a short-term challenge. The first one is the ever-increasing surface of exposure of our industry to the cyber attacks. It's not only the aircraft itself or its surrounding tools, but it's everything related to the Internet of Things. We see more and more features, connected baggages. We see RFID tags communicating with the outside world directly from the box in the avionics bay. A lot of things are currently happening in the world of Internet of Things, which brings cybersecurity issues as well. There is a question that we are tackling about the connectivity of legacy aircraft, whether it's legacy helicopters or legacy airplane. It's really a topic because there is so many flying legacy aircraft. How do we deal with cybersecurity threats on that flying objects? And so I don't want to spend most of our time on that topic, but I'll be happy to answer a question about that. The second topic that we are really looking at in terms of coming challenges, the very rapid increase in the attack power that our adversaries have. It's not buzzword, it's not bullshit, but the rise of artificial intelligence in the field of cybersecurity, it's something that I've never seen before. I mean, the DARPA has already organized the world first all-machine hacking contest. So imagine that you had machine attacking machines, okay? And this was the first of its kind, but we are really looking at it because this is probably the next generation of issue we'll have to face. It's no longer some guys lost somewhere in some weird countries at the end, somewhere in the world, but it could be software robot someday, controlled or not by rogue people, I would say, but the attack power of artificial intelligence attack bots would probably overcome and surpass that of clever people. The third topic that we are closely looking at Airbus is cybersecurity issues in the Industry 4.0, where more and more aircraft parts are production and manufacturing is automated. And we are thinking about, we are talking about the cybersecurity of 3D printers, for instance, making sure that the parts fulfill the design constraints, but there is no vulnerability in the physical parts that has been manufactured or produced by these clever machines. And last, it's really something that is of concern because the market on cybersecurity, the market of talents, the market of talents on cybersecurity is very complex and difficult. And as I mentioned, this is a very asymmetrical battle. That's the beginning of this short presentation. And our objective is to rebalance this asymmetry, making sure that we hire a specialist in cybersecurity within our teams, and with the appropriate dual knowledge, both in cybersecurity but also in aircraft design. And this unique dual competency is very difficult to find out of the box. So it's our duty as manufacturer, and I'm sure Boeing is doing the same, to work with universities specialized in IT and cybersecurity, making sure that they acquire this knowledge of what is to design an aircraft so that they can apply their knowledge in our industry.
Thank you very much, Julien. I appreciate the insight on what Airbus's activities are, and we'll be discussing it a little further. I think I'm going to take the liberty to say straight up, I believe that Julien probably traveled the farthest for this conference. We appreciate you coming all the distance, all the way over from France. So thanks for joining us. Next up, I'd like to introduce Mr. Doug Booth. If you could tell us a little bit about what activities you're working with at Lockheed Martin.
Yeah, absolutely. And so Doug Booth, thanks for having me back again this afternoon. I've learned a lot today sitting in here from the kickoff this morning through the counter UAV session and all the other sessions. I really appreciate what ALPA is attempting to do, and we're here to support as much as possible. Instead of going through, what I had prepared, because there is a lot of overlap, I think, since we're standing between you and happy hour, maybe we'll try to expedite this a little bit. And I just want to talk deeply about a framework that's really helped us. It's helped the DoD community. It's helped the DHS community. It's talked a lot about on the networks. I think a lot of us are familiar with the Target Corporation that was hacked into several years ago. Congress put together a team, and one of the outputs from that team was if they would have adopted the Lockheed Martin cyber kill chain. It's not a product, it's just a framework. If they would have adopted that early on, it would have helped them circumvent some of the problems that they had. So it's something that I believe the FAA and ALPA should be talking about. But before I get there, cyber is in everything we do at Lockheed Martin. Not only are we protecting our customers' networks and our own networks and communication systems, but we also apply cyber to all the platforms that we build, whether it's the space-based platforms that a lot of you leverage as you're flying your planes today, the airline industry like F-35, the maritime and the ground and DoD industry. Cyber's in everything that we do. We support the National Threat Operations Center. We help the Air Force run the largest forensics lab at the Defense Cyber Crime Center. And we also run the National Cyber Range down in Orlando, Florida. So a lot of bona fides and a lot of lessons learned, right? It's not something that you do overnight. But probably one of the biggest things that I want to talk about is the cyber kill chain. A lot of people believe that, that an adversary only has to be right one time and they can get onto your network, they can get onto your mission system, they can get onto your platform. That's not the case. It's not true. We've actually mapped it out. The adversary actually takes 7 steps in order to get onto your network. And as long as you build a framework that's around those 7 steps and you understand the 7 steps, you can start sharing and collaborating with one another. Hey, where did I see an adversary come in? Otherwise, as you're reporting data and you're collaborating with your peers, the metrics don't mean as much. It also helps from a reporting perspective. If someone is making it to the 3rd step, that's when you would let a certain CSO know versus the 7th step, you might want to let the president know. But the 7 steps, mapped out, reconnaissance, weaponization, delivery, exploitation, installation, command and control, action on objectives, okay? So let me kind of go through this for a little bit. When you think about an adversary, when they're going to come in, and this is an advanced persistent threat, they only need a $1,000 computer connection to the internet, but the first thing they're going to do is reconnaissance, right? They're going to start looking for all the blueprints of your platforms, blueprints of your networks. This is something that there's tools and sensors out there today for you to be researching to say, hey, who's looking at my stuff? Whether it's Airbus or Boeing or Lockheed, FAA, DHS, you want to be careful what you're putting out there on the internet and making sure that if people are looking at your data, you can put sensors out there to identify that. So the first step that you want to try to protect and have tools to protect is reconnaissance. The next is, after they conduct reconnaissance, they're going to start weaponizing a system, weaponizing a payload. There's tools out there for do this. It's repetitive. As they're starting to build these weapons, they're of similar fashions. So you want to make sure that you're building something that's looking for that, or you have a third party looking at those websites to see who's visiting them and what they're pulling down. After they weaponize, they're going to figure out a way to deliver. That's when they start to penetrate your network. And so you want to make sure from a delivery perspective, you're mindful of ways that things can be delivered, through your network or through your phone systems, and deploy something that's looking for that. Exploitation is when they're going to exploit an anomaly inside of your system. So making sure that you have the proper procedures inside your system to batten down the hatches. Once they exploit a problem, the install process begins. After the install, and that's when you can monitor changes to your system. After install, they'll open up a command and control chain. They'll actually be typing and communicating with the exploit, and then that's the last step is actually performing the action on the objective. Are they stealing data? Are they erasing data? Are they modifying systems? And so if you take a look at this 7-step kill chain process and you identify the network defenses that you have in place. Do I have something that's looking for reconnaissance? Do I have something that's looking for command and control? Do I have something that's looking for action on objectives? You'll quickly identify all the holes that you have in your system. It's a really simple process. And then, instead of just being reactive and waiting for an attack, you can actually be more proactive. We call that an intel-driven defense system. And so you'll be able to monitor things coming down, and you'll be able to identify adversaries as they're coming in, regardless of what part of the world they're coming from, and say, hey, I see someone, they're actually at level 1, now they're progressing to level 2, level 3, I'm going to make that a priority. But maybe not as much of a priority if you're actually seeing things happen at level 5 and 6 versus 1 and 2. So it helps you prioritize as well. And then from an information sharing perspective, inside the DoD, we've established the Defense Industrial Base. Several hundred companies sharing information. And the one thing that we try to do is share information around this cyber kill chain. So that way, if I am not seeing something, but my friends over at Boeing are, maybe it's because my defenses have been penetrated and I need to change something. Maybe they have something that I don't. If you don't have the same type of defense model, it's really not going to help me if they're seeing something that I can't recognize on my system or apply to my framework. So just a little bit on the cyber kill chain as you're establishing your defense posture and your defense framework, something that's really helped the community as a whole.
Great. The 7 steps as you go through, you could see that when there's probing of an activity, is there a way to trace that? Is there a way to root back to the original, to the bad actor that's trying to do that? Is there any way we could follow along?
Yeah, I mean, absolutely. At our company, we keep a heat map, and that heat map identifies different parts of the world where we've seen actors come in. A lot of times, as we're collecting that information, we can tell, where it's coming from, and then we have an exchange with parties from around the DoD and Intel community about the different campaigns that are coming in. So it is, it's not simple, but if you're tracking and you keep a heat map for these things, you will be able to identify where they're coming from. And then if you establish a relationship, for example, with the National Threat Operations Center, that's something else where you can share data that you have with them, and they'll be able to help identify these adversaries that are coming in.
Is that data center available to all suppliers that supply to the manufacturers or folks that have inputs into the airspace system, be it from an airport standpoint or from an airline or other folks in the aviation business? Does everyone have a seat at that table?
I don't know about all the seats at the table, but I do know that they interact with all of the threat operations centers, security intelligence centers. Industry communicates with them as well. So I do believe it's an open communications channel. I believe there's also been folks from the financial industry the healthcare industry. So I think this is just another vertical that can probably easily establish a relationship if they don't already have one with the NTOC.
Are you running your own CERT, Center for Emergency and Response Team?
Yeah, inside of Lockheed, we run our own CERT team. We're also a CIRA Critical Infrastructure Response accredited by NSA. There's a dozen companies inside the U.S. That are certified to respond to national infrastructure incidents. And so that's one of the other things that we do is supply that type of talent and capability. And my peers do as well. We're not the only company in the U.S. or in the world to do it. But we do believe that sharing and collaboration is something that's going to be a success for us, and one of the things that we want to continue to do to stay in front of adversaries.
I'm going to ask a very broad-based question to our panelists and the folks that are in the audience and on the internet. By all means, please send in any questions you have. You could text those in, and we'll be happy to bring those up and discuss them. This is very, like I say, broad-based, 35,000-foot view. What do you see as the highest cybersecurity threat to commercial aviation and to our aircraft today?
I'll start. I think
sure.
The biggest, there's multiple threats, right? There's threats to the ground communication systems. I think that's the easiest thing for anyone to get a hold of when they're connected to the internet. If you're not consolidated, if you've got multiple gateways, that's probably the simplest threat. I think but the damage that can do versus if someone gets access to your mission systems, your GPS systems, right? And you may think that you're 100 feet off the ground, and there can be a lot of spoofing that goes on there. So I think the biggest threat from a safety perspective, from a flight safety perspective, is the actual airframe and air guidance systems.
To turn it around a little bit, I'm not staying up awake at night worried about the aircraft systems. We have long had very stringent requirements from the FAA to make sure that the aircraft is safe. When we do software loads, what was mentioned here, it takes 2 years for a software load. The reason it takes 2 years for a software load is we have a very stringent process to develop the software, test it, prove that it cannot break so that the aircraft has a safety problem, and we've been doing that for decades. Processes are out there. That gives us a very solid footing to stand on. We're now looking at some of the margins because that takes us from the unintentional error into somebody with very ill intent, so we want to look at that. So I'm not staying awake for the aircraft systems because we have a good track record and we have really smart people working on it to make it even harder. The threats that are out there that you have seen in the press, they're going to be focused much more in the near term, in my view, on service disruptions. If you get beyond the safety of the aircraft and the ability for a large international airline to do its operations, how they run their IT system, passenger reservation system, so forth, they're not built to FAA standards. They're built to IT standards that are pretty good, but the ability to, and the number of people involved with those kind of systems without the degree of protections when it comes to passenger reservation systems, credit card systems, and so forth, that's where we've seen the bad actors try to hit us so far. They've tried to pursue us in many cases with the intention of a financial benefit. That's why the credit card systems out there are so interested, or disrupting the websites. That's what we're seeing so far. So if your question is focused on what are we going to see the most of, especially in the near term, is on those kind of systems that don't have the type of pedigree that we necessarily see on the safety systems that we have spent decades and decades and decades hardening in the years past. We have work to do. Every new system requires some more attention on it. The regulators and industry is paying close attention to it, but it's the other systems that, for service disruptions, getting from point A to point B, getting your schedules, that's where we're seeing a lot of attempts occurring out there in the system. Do you agree?
Exactly. Those are the two topics that I wanted to mention. The first is not in terms of threat, but risk on critical avionics software. It's a secret for no one. It's top on the risk list. It's been discussed with the Airworthiness Authority for now decades, and that's why there are now strong mechanisms to protect the integrity and authenticity of everything we upload on board the aircraft. So it's still on the top of the list of the risk. It is a managed risk, so we are now confident. But in terms of threats, yes, I agree with you. It's everything related to the disruption of the second or not priority system on the ground, system that are used for maintenance, etc., for which there wouldn't be any safety impact, but would cause a business impact to our operator, and for which there is very few or no regulation, because it's mainly IT-based system. It's not part of the certification processes for most of it. And this is where, in terms of business impact, it hurts most.
Most definitely. And I think that jogs into another question of, we've seen a lot of airlines and operators have some glitches recently in the past 24 months where we've seen massive computer outages, failures of systems, operating systems. I know that you don't represent airlines here, but has there been any discussion in any of these stakeholder groups that perhaps that those were some bad players trying to work into the system, or any sort of attempts on the architecture of the computer inside the airline?
Well, this group that has been mentioned is the Aviation ISAC. We like abbreviations. It's an information security framework that's been stood up here. It's proliferating around the world. And in aviation, but also a number of other issues, data sets you free. It's how we work. It's run out of here in the suburbs of DC, and anybody involved with it gets frequent updates about what kind of threats are out there. And it's not only aviation threats, but some of the more advanced systems or the financial institutions, they have their system. There are others out there as well. When you're looking at what they're sharing information about, I am on the once a day update about what we saw in the past day. It's very much focused on traditional IT. And those systems, which are well known to the nefarious actors, they're using the types of computer systems that you can go, in many cases, down to Best Buy and buy that kind of computer and run your tests on it before you try to do something bad. That's what a lot of the data sharing is occurring around today. One of the benefits we have as an aviation industry is that most of our systems are not available to buy at Best Buy. We use different kind of computer system, proprietary code, and things like that. So that provides us that baseline. But the threat data there is very much, sorry, not threat data, the information sharing that we're seeing occurring, especially through the AI sec to address this problem, is very much focused on those ground systems.
Yeah, I haven't heard anything about the actors that were coming in and disrupting. I haven't heard any reports at all about that, so I really don't have any comment.
Okay. So we've established that that a lot of the probes are for money purposes, credit card hacking, that sort of issue, to try to get monetary gain. I'm sure probably a very close second would be design and proprietary information. I'm sure corporate espionage type issues. Is there a way to determine the probe and exactly where it's headed or where it's going once it does enter into the IT structure at an organization? I mean, is there a way to backtrack? I have an AOL account, so I'm asking the professionals here. I got to be honest with you.
You do want to figure out what their intent is before they start to come in, and that usually happens with the reconnaissance capabilities. There's a lot of there's a deep dark web out there where there's a lot of tool trading going on, and depending on what you're trying to do is the type of tool you're going to get. So if you're trying to go after the financial markets and you're hitting my friends in that market, you're collecting that type of tool. If you're trying to download data from an IP perspective and steal intellectual property, that's a different type of tool, and that's what we've been seeing lately. The next big wave that a lot of the forecast is around is infrastructure damaging. And so ICS and SCADA type capabilities and operational technology. We've talked a lot about standard IT, but on our ships and on our planes is what we call operational technology, not so much the standard IT, but the operational technology that is somewhat proprietary, but is also building into these open standards. And so there's a concern that the next wave is going to be this infrastructure, derailment. So yes, they're going to keep hitting banks as long as they keep getting money, and yes, they're going to keep stealing intellectual property. But there is going to be a shift, and this next wave is going to be on infrastructure, and that's based off of what some of the people have been seeing from a sensors perspective. So you can't, I don't know if you can really tell, once they get in there where they're going to go without a little bit of research. There are some capabilities for doing hunt missions inside your network. So a lot of these adversaries just sit, lay, and wait once they get in. They don't really activate anything, so there's hunt missions that go on inside of your OT and your IT network to see what's going on. So I think that's something else that's really been ramping up over the last 6 months.
Yeah, and maybe to jump in on that, what we're seeing a lot of conversations occurring, you see it written up there, is smart hygiene with respect to IT security among your employees. I assume your password on AOL was not 12345 or password, which are surprisingly frequently used. But just going out there, and anybody who is on a corporate network or even your home network, there are some things that you can do that are for ease of use, but it sure does expose you to certain types of abilities to get into your own personal information online these days. The events that have happened have involved people clicking on a link on an email from somebody that looks kind of like the right person, but they're not really when you look at the address from which they're sending. Step one in a protection is just educating the staff and the employees about how to be smart about that. If you have a computer, this would be an extreme case, but we discussed, as a manufacturer, if I let you connect a laptop to the aircraft, part of the instruction I'm telling you is make sure that that laptop is secured in a certain manner. You want to, I'm simplifying this vastly, but that laptop will obviously have a pretty good password on it. I will probably ask you not to connect it to the internet unnecessarily. And if you want to put your own apps on it, I'm probably going to discourage you or tell you no. I mean, that's a very simple step, but it's the kind of step that gets you 80–90% of the way there to at least avoid something really, really stupid happening as a corporation or as a private person. So even that fundamental education about the things that the company isn't going to do, but it needs every employee to do smartly, that's what I've seen be kind of the first step as we look at some of these, as we are all learning about cybersecurity and steps that everybody can take. Fair?
Yeah, I would like to add, and share that I cannot agree, and we cannot agree more with your evaluation of what would be the next wave of cybersecurity concern. We share the same point of view, and for those who are not used to this kind of topic, you can find publicly available information on exploits in other industries where the industrial and production means have been successfully attacked by a blackmailer. I'm referring to this German steel mill. It was blackmailed, and they didn't want to pay, and they had their oven blowing up because the hackers were able to lock the pressure valves in their production systems. So it's happening in the real world, in some other industry, and then yes, we have to look at it closely.
Yeah, the education is something that we're really passionate about, and it's a culture inside of our company. It's not just about going out and training and warning, but we actually have live events, unknown to every individual, 125,000 people, at our company, where we would send, fake emails just to see what would happen. And if an individual clicks on something that they shouldn't have, once, is punishable. Twice and 3 times, you actually raise the stakes for what could happen to you as an employee, and no one's off limits inside of our company. That's something that our CSO talks a lot about. So training is, cyber training and education of the workforce is a culture thing that you must adopt and spread.
Interesting. Is the range of technology in use today a hindrance, or is it a protection or an advantage to an operator using certain aircraft? We have aircraft that are 40 years old, up to a year, say in the case of the A350, highly technological. Is it an advantage to have a older model aircraft, or is that easier to get into? Or does the higher technology aircraft create more opportunities, or is there better guards in place for these advanced aircraft?
All aircraft are certified to the same standards. The security requirements are placed within the airworthiness code that ensures that the aircraft is airworthy. And in neither, the FAA is not identified, or have other regulators, a type of breach into the aircraft, whether it's a new or legacy aircraft, because we have a very sophisticated system. There are different challenges with new and old aircraft. If I have a legacy aircraft, it tends to be completely federated, and while it may have some input-outputs electronically, they are of such wonderful vintage, and they are not connected to the internet, that there's some inherent protections there. If you read the FAA's guidance, I can paraphrase it. It says, if you connect your aircraft to the internet, identify the connection, analyze it, mitigate it, and show us that that connection to the internet is safe. If it is not safe, it's not going on the aircraft. So it's not a comparison. In aviation, we make things that meet a safety standard. And the difference in the exposure directly is that connectivity to the internet. And we don't only look at that in you plug into a cable. The connectivity to the internet can be how you load software. If you have a maintenance computer, the manufacturer blasts out a new software, they download it at their IT station, they give somebody some kind of media to put it into the aircraft, that aircraft is indirectly connected to the internet. And the FAA tells us, how do you manage that? How do you prevent that something bad ends up in the aircraft? So it's not a good, bad, different. It's a different approach to achieve the safety objective that the aircraft is airworthy.
Should aircraft be physically protected, say on a hard stand or a ramp area where it's not being used? Should security be provided to protect from, say, the person bringing on a stick, bringing on some sort of a data loader, or loading onto an aircraft into the systems? Do you feel that maybe we should have some security and protection for that aircraft while it is on the ground?
Yes, this example is one out of many security features and mechanisms that are implemented on board a modern aircraft. They imply either technology, security-related technologies on board, but also, as I mentioned, specific procedures on the ground. So it's a combination of strict behaviors when performing maintenance. That's why we deliver a security handbook, but also some strict security control, technical ones, on board the aircraft. You mentioned data loading, and I mentioned it as well. It's one of the very first aspect of cybersecurity that we addressed with very strict digital signature mechanism, where the signature is verified on board the aircraft prior to upload the critical avionics equipment. So it's both technological answer and procedure, manual human beings behavior.
Yeah, I mean, I don't know what the processes are today. You know, when they're sitting unoccupied at a gate or in a hangar. But if you have, it's a 21st century computing platform, right? And if you have security measures built in, anti-tamper capabilities built in, then I think you're safe. If you don't have those, right, and you don't have some sort of certification and authority to keep it unmanned, then you might be at risk. But I'm just not aware of what the processes are today or what's implemented on the aircraft today.
We talked about supply chain and folks that provide smaller items on board an aircraft prior to installation, or maybe aftermarket items. Julien, a question for you. What do you require of your suppliers prior to doing business with Airbus before they're able to install their equipment on your aircraft?
Yes, once we have looked at the security of the aircraft itself for so many years, then we went up the chain, the supply chain. And immediately it appeared that it's as important to make sure that our partners and suppliers apply the same standard as us than anything else. So I would say that very early, I would say in the 2005, at the time of the beginning of the A380 program, that's where the first requirements toward our suppliers were addicted and part of the contract, of the supply contract we have with our suppliers. We are talking about big names here, Rockwell Collins, Thales, Safran, etc. People who know the job. And 10 years ago, it was a very new topic. 12 years ago, it was a very new topic in the discussion with them. Even our procurement department was not ready to discuss this part of the contract with our suppliers. 12 years later, it's much easier, and it's not systematic. As I mentioned, it's a risk-based approach, but for those equipments or hardware that deserve it, there are specific requirements in the contract, and they have basically, to summarize it in one sentence, they have to conduct what we do internally, a risk assessment, and they have to demonstrate to us that they have done everything that is possible to avoid any vulnerabilities to be installed in their product, whether it's a physical vulnerability or a software vulnerability.
So from the policy wonk guy as opposed to the real world where Julien is at, when we looked at the rules, as a manufacturer, I'm already required to control my entire supply chain. The requirement is you control your supply chain to ensure that the aircraft is safe. I have a type design. I then set up a system. As part of that system, produce the aircraft. I have to control the supply chain. A lot more details into that, and as was discussed, you go out and audit. You have a risk-based approach to it. Certain systems get different types of attention. But when we looked at it from the perspective, do we need a new rule? How do you control your suppliers? We said, no, that rule has already been on the books. What we needed to do as an industry is that evolution and say, in addition to checking that the metal being used is the metal that is in the type design, that they have a quality system to make sure that they are making parts that meet that quality system, that we go out and audit them to make sure that they're doing what we told them to do. There's now that additional component to say, okay, this is a system that has critical software, whatever else is in there. How do you as a supplier for my aircraft production ensure that you are not introducing something bad there? So in the aviation, we're a pretty mature industry. We have a lot of regulatory tools and other things here. This is, putting it from the system engineering perspective, this is a new requirement that I have to look at, not only from when I design the aircraft, but also when I produce it and throughout the entire supply chain.
The thing I fear is, say we have fly-by-wire or engine-by-wire equipment and it starts to fail. How do we know whether that's mechanical or that's a bad actor? And I believe that if we can determine by some way, shape, or form, and if there's indicators coming in the future through your R&D work to maybe let us know that this is a malicious code, this is a virus of some sort, that we're able to interject ourselves into the equation and disarm the code or something to that effect. Like I say, my password is only QWER1234. I didn't say that, but when you start talking about, the pilot has to be in the loop, what extent do you see as a manufacturer, Julien, of giving that pilot the opportunity to say, take over some of the data and hierarchy architecture inside the aircraft?
I remember having had this discussion, similar discussion with pilot representative from our launching companies for the A380 program and A350. We had this kind of discussion along with specialists in human factors, how to best provide the pertinent information to the crew so that they are able to react in case of a cybersecurity issues. I can give you the conclusion. Our customer's pilot said that they They wouldn't need and want to be involved in taking a decision based on approximative information. And they prefer, so it's not representing all pilots, it's only a subset of pilots with whom we worked on that topic during the development of our aircraft. But as long as we are not sure 100% that there is a cybersecurity attack and they have to react, it's no need to show them this information. So at the end of the day, you don't find in the cockpit any cybersecurity related information available to the crew. And we are just listening to their need so
it's probably fair to say that our goal is to avoid that ever happening. We don't want that scenario, right? The same way I don't want to have you being put in a situation as a pilot where you have safety alerts going off. I want to design a system, like I discussed early on. I design the aircraft, I produce it, and then there are instructions to the aircraft operator and especially the mechanics on how to ensure that that aircraft is secure before it goes flying. So we've spent a lot of time and energy to make sure that that upfront security before you go flying is in place so that you're not seeing something on a cockpit display in the scenario that you see there often discussed that you as a pilot would have to try to figure out what it is. So that upfront thing is, you know, we want to try to eliminate that problem from the crew so that cybersecurity is not a new component to the many other things that you as a crew is dealing with. Now, there may be a role for you as part of those mitigations, right? We provide those instructions. We provide them currently very much focused on the mechanic. In the same way I provide instructions for continued airworthiness for safety, I provide the same type of ICA that now also includes security. So the same mindset that we have here in safety being applicable to security really lends itself to this environment as well. Doug, did you?
Yeah, I just add, I mean, I agree, risk is extremely low. But one of the things that we've done is taken pilots, you know, flying overseas in theater with their platform into a cyber tabletop exercise. And you can run them through the cyber tabletop exercise, apply you know, known malware to their systems and disable different functions. And in most of the cases, they can, you know, land the plane. But it does give them some sort of knowledge as to what could happen, what may happen, what to look for. But it would be a long education process, but it is something that you could potentially do. You know, you train a couple people and then maybe put some videos out for people to understand, not to, you know, get everyone upset or nervous about the situation, just so they, there are people that are working on things like that, and one of them is the cyber tabletop exercises for pilots.
Thank you for saying that, because maybe it was not clear, but yeah, we are for what is related to critical and flight functions. Of course, thanks to air gaps and mechanisms, as you mentioned it, a pilot will be able to fly in any conditions. We are talking about secondary systems where you have connectivity, in-flight entertainment, for which, and I should have been more precise, our pilot panels didn't want to hear from it. I mean, they are here to pilot the aircraft. As long as we have demonstrated that thanks to air gaps and many mechanisms, nothing can happen to critical functions, the rest is down on the list.
Good. Any other questions? Got one here.
Yeah, hey, good afternoon, Bridger Engineering Air Safety. So, you know, we talked about, you know, aircraft as it relates to pilots. What about, yeah, as aircraft are transiting domestically and internationally and their exposure to different networks as they go around the globe? Is there, has there been some discussions there about how it's interacting either in airborne or on the ground, and you know, what those concerns are?
Yes, I mean, the aircraft and the standards, and this was really one of the critical things when we stood up the rulemaking committee, was to have players for all the main aircraft manufacturers there, because, you know, GAMA members are not making aircraft for the US market only, that we make it for the world. Airbus probably sells more aircraft outside Germany, France, and the UK than they do anywhere else. So these aircraft need to work there. So there are some specific considerations. It would be an engineering deep dive to go into it, but I'm basically out there and looking at what can I trust that are out there in the network and what can I not trust. And that is, to a great extent, agnostic to where in the world I am, because I make an aircraft that flies anywhere in the world. So it's part of the considerations. It's part of the things that the manufacturer, as part of certifying the aircraft, has to show. And as an airline, operating into those regions, you have to have processes in place. Many things in aviation these days, we'll focus on process, ways to manage risk, not only for safety, but for security. So again, hate to repeat what I said earlier, but that safety framework really lends itself to managing that risk right here.
Any other questions? Got one here.
Without getting too deep into SSI and all this, can you guys comment on what sort of steps we ought to be considering in the future to help mitigate those sorts of operational security issues that might crop up with the proliferation of connectivity that would occur? And I also want to mention that, the FCC was going to stand up an interagency group with the FAA and help resolve a lot of these issues. Now, with the new administration, the FCC seems to have removed themselves from the cybersecurity issues to some extent. They withdrew their white paper. So here in the US, we're kind of at a question mark point.
So quick answer on that one. First, the regulation. Second, so we comply with the regulation. So we have to demonstrate, it's always a risk-based approach, and during the certification process, we have to demonstrate to the authorities that no unsafe condition can arise as a result of a cyber attack. So this implies to demonstrate that any potential cyber attacks originating from in-flight entertainment or public domain cannot harm critical flight function. We do that. We do this demonstration with a technical demonstration on our air gaps between critical system and the rest of the world, etc. Second, part of the answer is that once we have eliminated any risk on an impact on the safety of the flight, then it's a matter of demonstrating that the operation of non-safety related operation of the aircraft can be maintained. So then the demonstration is both with the regulator but with our customers as well, to demonstrate that thanks to the technological mechanisms and the procedures that we impose, the risk is maintained as an acceptable level, I would say. So the increasing, we see a lot of and we claim it's an increasing connectivity of the aircraft, but actually it's not that more than it used to be 10 years ago. Once we have opened an internet access to the in-flight entertainment, it was there, and nothing more has been done since then. So the risk that we are mitigating now since 12 years or 15 years is about the same today. The means are slightly different depending on new generation of aircraft, but generally once we have eliminated this safety-related risk, the operational risk is, I would say, not business as usual, but it's standard IT security and cybersecurity concerns and mechanisms.
Gentlemen, thank you very much. In closing, I know this is an area where so many questions remain unanswered and where there's still a lot of work to be done. It's my hope that this panel sparked a desire in our audience here today to continue to ask the questions and to continue to stay vigilant of the risks that could be out there. I want to thank each and every one of our panelists here and for our audience for participating in the discussion. Thank you very much, gentlemen.
Thank you, Steve. Thank you.